In example 2, we have a few graphs to solve, and we're going to solve each system of these inequalities by graphing. For A, what we can do right away is graph the first one. It's already in slope-intercept form, and I'm going to do this one in green, and I'll do the next one in red, and then I'll do the solution here in purple. So the graph in green, y is less than 2x plus 4. That would be y-intercept of 4, and then the slope is up 2 right 1 or down 2 left 1, and you could take this as far as you wanted to go here. That would be fine. And then it's going to be a dashed line because we don't have an equal to sign here. If you have a straight edge, it's probably a good idea to use a straight edge here. I'm just kind of doing this by hand. There you are. We also want to shade. So if the line doesn't go through 0, 0, it's a good idea to choose that for a test point. So what I'll do is I'll just make each variable 0. We're testing this point right here. And we get 0 is less than 4. Well, 0 is less than 4. So the ordered pair 0, 0, or the origin, is a solution. And the cool thing is you don't have to check all the points on this half of the line. If one of them is a solution, then all the rest are a solution. So what I'm going to do is I'm just going to shade here all over on this part. Now, if you're shading with a pencil, which you should be doing this in pencil, it's going to be, try to do a good job shading, but do it lightly, Now for the next one, we have to adjust it just a little bit. So what we'll need to do here is subtract 2x. So we have negative y is less than or equal to negative 2x plus 4. Then divide by negative 1, and we get y is greater than or equal to. Remember, when you divide or multiply by a negative value, you flip the sign, and then it's going to be 2x minus 4. So we can graph this one as well. We can go down 4, and then we're going to go, let's see, up 2, right 1 as well. And we'll go up 2, right 1. So what happens is these are parallel, but I think there's going to be a solution to this one. Unlike a regular system of equations, rather than inequalities, then there might not be one for those. But let's just talk about this one. So you've got an equal to sign there. It's going to be a solid line that goes right through those points right there. The key is whether or not there's an equal to symbol underneath. We also want to try to do the same thing we did before with this one. I'm going to go back to the original. The line doesn't go through 0, 0, so it's a great choice for us. So we've got 2 times 0 minus 0 less than or equal to 4. So we've got 0 is less than or equal to 4. Well, that also is true. So this point works, which means everything on that half will work. So I'm going to try to shade all of that right now. You got to imagine that the green stuff isn't even right there at all. So this one's going to be our red graph. Now the key with this is to find the overlapping region or the overlapping area. In this case, we see both red and green in between these two lines right here. So in purple, I will try my very best to give you the actual solution region to this system of inequalities, only in here. If you're doing this in pencil, what you want to do is after you've shaded lightly with the green and the red, obviously if you're using pencil it's not going to be red or green, it'll be gray. Where you double shaded right in here is what you want to really darken in. So make sure that you really darken that in. Don't go past that line, don't go past this line. The reason why this area isn't a solution is because it only works for the one in red, not for the one in green. Here, this area only works for the inequality in green, the first one, but not for the one in red. It's got to work for both, and so the overlapping area is the one that you want to shade in. If we begin the next one, we'll keep with the same color system here. We'll do the first one in green. So that's a y-intercept of 5. The slope is negative 1, so I'm just going to plot that real quick. I hope that you know how to graph a line that's in slope-intercept form. If not, you might want to go back and review that a little bit. So what we need to do here is we need to draw that line. It's got an equal to underneath it. So we're going to just go right through each one of the diagonals of those boxes right there. We can choose 0, 0 again. That's our test point. And we'll just substitute those values in. So we've got 0 is greater than or equal to 5. That, of course, would be false. So 0, 0 does not work for this one, which means none of the points here will, but everything on the other side of the line will. So I'll do my kind of marker shading here, and of course if you're using that pencil, then you just do it nice and light. We'll do the next one in red, and then we'll do our final solution region in purple. So we've got less than or equal to 3x minus 4, so y-intercept of negative 4. The slope is 3, so that's up 3, right 1, or down 3, left 1. There's an equal to sign underneath, so we're going to draw this with a solid line. Only when there is not the equal to sign there do you use a dashed line. That means, in the dashed line, that means that points that are on the line aren't actually solutions. With these solid lines, though, that does mean that points that are on the lines are solutions. Let's take a look at the test point. This red line doesn't go through 0, 0, so we're going to use it as a test point. And all we do is just take each one of those variables out and substitute in. We get 0 is less than or equal to negative 4. Well, that's false, so we're going to shade not over the origin, but we're going to shade away from the origin, which would be this direction right here. The double shaded area, once again, is our actual solution area. And so what we need to do is really make that apparent which one that is. If you think about it, there's going to be 1, 2, 3, 4 quadrants, as long as your lines intersect, that you're going to be looking at, and one of them is not going to have any shading. It's not going to work for either one. A point in this area would not work for either inequality. It would make each one false. Here, this part, it just works for the green one, but not the red one. Here, it just works for the red one, but not the green one. And only in that double shaded area is where it's going to work for both of them. So do a good job, shade that in. If you're using pencil, do it nice and dark. Alright, just a couple more of these. I kind of like these graphs myself. I think it's fun doing a little shading, doing a little coloring. Try to keep it in between the lines though. And for this one here, all we need to do for this first one, oops, should have chosen green, so maybe we'll stick with that. It's just divide everything by 2 to begin with, and we get y is less than, I'm going to change sides on you here, so that smaller end's pointing towards the y. And then we're going to have a 2x plus 2 there. So we can go up 2, and the slope is also 2. And let's see, keep going, we'll keep going. We have a less than symbol without an equal to, so we're going to need to do a dashed line. Make that as dashed as I can. Some people call this dotted as well. It means the same thing. It means that anything that's actually on the line isn't a solution. We'll try the next one, and what I'll do is perhaps do that, well, we can just do that here at the top, I guess. Subtract 3x from each side. All we're doing is we're just changing into slope-intercept form here. You need to, if there is an x term by the y, you need to subtract or add that to get rid of it. And then we'll divide by that coefficient here of y. So we've got y is, less than or equal to, flip the sign, 3/4 x plus 1/4. Ooh, kind of a crazy one. Well, a quarter is going to be right here. And you can imagine with this one, if we went, let's do this. Let's make the slope 3/4 over 1. So the y is going to be up 3/4, right 1. And then we've got another point there on the line. Then we could go up 3, right 4. Up 3, right 4. And then we could go down 3, left 4, down 3, left 4, and so on. And what we'll do then is we will go ahead and draw a solid line through these. There we go. And one thing we forgot to do is shade here for the last one. So let me do that green one for you. The green line doesn't go through 0, 0, so I'm going to choose 0 to see what happens here. And by the way, I'm going right back to that original. I always go back to the original. If I've made a mistake with my negative sign or something, like down here if I didn't flip the sign, then it's really going to throw things off quite a bit. So we've got 4 is greater than 0. Well, that is true, so we will shade towards the origin. I'm just going to kind of do it a little bit lightly. Right here is the origin, that's the point we tested. It made the inequality true, so everything on that side of the line will be we'll make the inequality true. We'll shade over it. Let's do the one in red now. We'll do that right here. So the line in red, it gets real close to 0, 0, although it's just 0, 0 is just a little below it, and it's you can see that if you look close enough. So we'll use it again. And if the line ever goes through, oops, kind of getting the other graph's business here. If the line ever goes exactly through the origin, just pick another point. Like we could have picked 4, 0 if we really wanted to. Well, let's see what happens here. 0 is greater than or equal to 1. Well, in this case, that is going to be false. So we are not going to shade over the origin for this one. And what we want to do is shade on the other side. Let me just make sure that that is actually true here. Let's see. I made a mistake. Made a whoopsie. This should have been -1/4 here, right there. So really, this has to go down just a little bit. So we would have to shift this down just a touch here. The slope's not going to be different, but that line is going to be right here and right there. So pay no attention to the one in red. Actually, we're going to be shading over in this case. Let's see. Well, we won't be shading over it. Sorry. We've got 0 is greater than or equal to 1, which is false. So we're going to shade on this side down here. So it's this second red line here is the actual line. Kind of a drawback of doing this in pen, I guess. So we'll just shade this in purple real good, and this is going to be our actual solution area down here. There we go. Let's see if I can do a better job here on the next one. X is greater than -3. Well, that's an easy one. So x is -3 is a line that passes right through, vertical line that passes right through -3 here. And we're going to be x is greater than, so we want all the x's that are bigger. So those are over here. Yes, those aren't too bad. And then the next one here, of course, we'll do the second one in red. Let's see, we just have to add 3x to each side. So we've got y is greater than or equal to 3x plus 6. So there's our 6. There's our slope of 3. And let's see, when we draw the line, it's going to be a solid line. Go down 3 left 1. So we'll just draw a nice line right here. And there we are. And we're going to choose a test point of 0, 0 here for this one. So we've got -3 times 0 plus 0 is greater than 6. 0 is greater than 6 is false. So we will need to shade everything else on the other side. And then you can see this double shaded area is going to be right in here. It's a little bit smaller of an area, but that's okay. So we want to get everything in there. We want to shade that in nice and dark.